Hello friends, welcome back to the Mastering Design Patterns series. In lesson 3, we will dive deeper into the Singleton pattern by exploring two critical aspects. Number 1, handling multi-threading issues, and number 2, implementing lazy instantiation. These concepts are crucial when working with large applications. So stick around until the end. If you haven't subscribed yet, hit that button and share if you find the video helpful. Without further ado, let's get started. Let's quickly recap what we learned in our previous video. Last time, we introduced the Singleton pattern, solving a problem where employees logged their hours using separate files by switching to a shared file. We also posed two important questions. Number 1, what happens if multiple employees log hours simultaneously? And number 2, how can we avoid eager loading? Let's answer this at the code level. So, in our previous video, we learned how to convert a class into a singleton class. There are 5 steps involved in it. Do you remember them? If not, let's quickly revise. Step 1 is to make the class sealed. Step 2 is to create a private constructor. Step 3 is to create an instance variable which will be private and which will hold the actual instance object of this class. Step 4 is to create a public static method which will return the instance of this class. And step 5 is the actual method which we want to call. Now there were a couple of problems that we discussed in the last video. The first problem is the new keyword is initialized here itself. So whenever the application loads, at that time itself, this object is created. But what we want is whenever we call the singleton class, then only this instance should be created. So for that, I will instance from here and I will put it here. And I want to instantiate only if this variable is null. Otherwise, whatever is the instance that I want to return. So with this simple step, now our class has become a lazily loaded class, where only when we call this instance, this is getting created. Now, let's discuss the second problem. What was the second problem? What if all the employees try to access the shared sheet at the same time? What will happen then? For that, what I have done is created 3 threads and a method. In this method, so they are trying to create the instance at the same time. So let's see what happens. Right now, in our bin folder, everything is empty. Let me run the program and see what is the issue that is happening now. See, we got the error. Why? Because all the 3 threads started executing simultaneously. And since we don't have any locking mechanism here, we got this error. We have to make our class thread safe now. For that, we have a very unique keyword in C# which is lock. For using the lock, first we will create object. I will create an object. You can create any object with any name. For now, I am creating lock object. And for locking any particular area, you can use the keyword in this way. Lock. And that's it. And here also we will implement the lock because here also we are accessing the shared instance. Now, if I will run this program, I won't get that error. Let me delete this first. Now, let me run it again. With that simple change, now we didn't get any error also. And let's see whether the entries are proper or not. So the entries are also proper. So to implement lock mechanism in C#, we have this lock feature. Now there is one more problem here. Here, if you notice, we are locking the object every time. Even if the instance is null or not null, we are trying to lock it. But what we want is only if the instance is null, then only lock. Otherwise, don't lock. So for that, we will use a double locking mechanism. With this simple change, now we have double locking feature. The output will be same, but the performance will increase because we are locking only when required. So in this way, we have resolved both the issues. First was multi-threading and another was the instance was getting created here itself. Now, instead of doing this much work, C# has a lazy keyword. With the help of that, we can avoid this many lines of code. By implementing it, we will make the class thread safe also. So let's see how we can do it. So I will remove everything from here. And I will make this instance a lazy instance. Lazy instance variable. And to implement it and to initialize it, I will use this. And here, I will initialize the object. Now, since we are using the lazy keyword, we can't access the instance directly. We have to use dot value. Now, we don't require this lock also. This lock is required. Why? Because here we want the locking mechanism. But if you notice, from here we remove the lock. Now, if we will run, you can see there is no issue. Again, if I will delete that shared file and show you. So there is no issue here. With this implementation of lazy keyword, we were able to achieve both things, multi-threading also and performance optimization also. So these are the various variations of singleton pattern. Now that we understand that what, why and how of the singleton pattern, let's discuss its pros and cons. Let's first discuss the pros or benefits of singleton pattern. Number 1, controlled access. It ensures that only one instance exists. Number 2, global access. It makes it easy to share common resources like logging or configuration settings. Number 3, lazy initialization. It saves resources by creating the instance only when needed. And number 4, let's look at its use cases. Logging services, database connection pool managers, cache managers, or configuration loaders. In this use cases, you can use singleton pattern. Now, let's look at some cons or disadvantages of singleton pattern. Number 1, global state. Because state management is at global level, it makes dependencies harder to manage and track. Number 2, testability. Singletons can complicate unit testing due to its hidden dependencies. And number 3, concurrency issues. Without proper locking, multi-threaded applications can experience problems. So the question arises, when should we avoid them? When you need multiple database connections or flexible unit testings, in those kind of scenarios, you can avoid singleton design pattern. Now, it's quiz time. Let's see if you have been paying attention or not. Question 1. What is the main advantage of using lazy keyword? Eager loading of single instance, lazy loading of single instance, or faster instantiation? Number 2. What does the lock keyword do in the singleton pattern? Prevents instantiation of new objects, ensures thread safety by locking the block of code, or disposes the singleton instance. And number 3. When is the singleton instance created in lazy instantiation? As soon as the program starts, when the singleton class is first accessed, or during compile time. Pause the video, solve the answers and message it in the comments. I will be waiting for your reply. I hope you would have given the correct answers. And to know my answer, please check the description of the video. Let's quickly review what we have learned today. Number 1. We solved multi-threading issues in Singleton. Number 2. We introduced 5 approaches to Singleton implementation: eager initialization, lazy initialization in non-thread safe manner, thread safe singleton with lock, double check the lock, and lazy singleton in C#. Number 3. We implemented these solutions in code. And number 4. We covered the pros and cons of the singleton pattern. Now, in the next video, we will learn about a new design pattern. Thank you so much for watching. If you have any questions or suggestions, please leave them in the comment. And if you found the video helpful, please like, share and subscribe with your friends. I will see you in the next video. Until then, take care and goodbye.